Welcome back, pre-calculus students, to our examining trig inverse functions. We're going to talk about, figure out what a trig inverse function is, what it looks like, and its domain and range right now using graphs and using this cool program called GeoGebra. Most of the pre-calc teachers have uploaded this file to their Moodle website, so if you want to mess around with it yourself, you're more than welcome to. You just need to download the program GeoGebra. So the first thing is we're going to start with this sine curve. If you watch the little inverse function video, you'll see that this thing fails the horizontal line test. I mean, we could see the x-axis makes that fail, which means that if we were to take the inverse of it, its inverse would not be a function. We need it to be a function. So what we're going to do is restrict the sine graph to a certain domain in order to make this thing, its inverse, a function. The restrictions are going to be where it passes the horizontal line test. And in this case, it's going to pass everything from pi over 2, from negative pi over 2 to positive pi over 2. As soon as I go beyond that in either direction, I start repeating y values, which means it'll fail the horizontal line test. Now, we're going to get rid of everything but that little piece. Graphically speaking, a inverse is anything that's reflected over the line y equals x. The reason why is, graphically speaking, the y becomes the x becomes the y. In other words, the domain becomes the range becomes the domain, and we're going to reflect that over that line. So we have our original sine function in red, and we have our new sine inverse function in blue. You'll see that a couple of the key points, the x and y's flip. Pi over 2 comma 1 becomes 1 comma pi over 2. Negative pi over 2 negative 1 becomes negative 1 negative pi over 2. 0, 0 remains the same. And any other key points that we know would hold true as well. Our final little frame is just to see what the actual arcsine inverse, arcsine, another way of just saying sine inverse function actually looks like. In this case, our domain becomes our range. So in our original function, when we restricted it, our range is from negative 1 to 1. Our domain now becomes from negative 1 to 1. Range gets restricted, the same thing as domain. We're going to summarize that in our notes. So for sine, what our restriction becomes from a domain is from negative pi over 2 to positive pi over 2. And that gives us the range of negative 1 to positive 1. So when we find the sine inverse, or the arcsine of this, our domain becomes our range becomes our domain, and we go from negative 1 to 1 up, and our range becomes from negative pi over 2 to positive pi over 2. Again, our domain becomes our range becomes our domain. In this case, we're inputting ratios. Our output are those angles that give us those ratios. Another way to think of this is not only graphically, but you can think of it according to the unit circle. In our unit circle, we need to represent all the possible y's that we can cover. So we need to start as high as positive 1, as low as negative 1, and we need to hit all the y values in between. To represent the positive, we're going to have quadrant 1. The negatives are going to be negative y values in quadrant 2, or excuse me, quadrant 4. The reason why we don't choose quadrant 1 and quadrant 2 is because those are repetitions of the positives. The reason why we don't choose quadrant 1 and quadrant 3 is because then we would have this gap. We wouldn't know how to get there. So we've chosen two quadrants that represent all the y values to have our domain be restricted to, so we get our range to get our output. In other words, we can our input can be anything, our output will be anything in quadrant 1 and quadrant 4. Again, the graph really quickly looks something like this, goes through 0, 0. Its range is as high as pi over 2 and as low as negative pi over 2. Its input could go from negative 1 to positive 1.